Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for tonight will be March 3, 2024. Okay, and the time is around 7:35 p.m. Okay, my topic for this evening will be a random topic. This will be an additional topic with my long video format subject matters. Subject matter that falls under, the solution of this falls under differential calculus and analytic geometry. So this is actually a very interesting topic. It's very useful for those who are planning to take up engineering. Okay, let's proceed. This is a random topic. This will be an addition to my long video format topics. Okay, I will try to read the problem. Find the slope of the curve at the given point 2 and 3, given the equation y equal to 3 plus 2x minus x squared, and as an additional requirement, sketch the curve. So the problem is just asking the slope. So under the study of analytic geometry, M is slope. So the topic for tonight falls under analytic geometry, and for the computation of the slope, to bring out the positive solution, we will be using differential calculus. So the topic also falls under differential calculus. That is, to expedite the solution of the slope, we will solve for dy dx equal to, and this is actually equal to slope. So actually the key to the solution of the problem is by knowing these two concepts here, that is under the study of analytic geometry. M is slope, and under the study of differential calculus, dy dx is actually m, and this is equal to slope. Meaning to say, if we are given a curve, and the problem specifies a point on that given curve, the problem is asking what will be the slope of the tangent line at the given point, that is m is equal to. Okay, so the topic is actually falls under analytic geometry and differential calculus. Okay, let's try to bring out the solution. We are given the curve, that is y equal to 3 plus 2x minus x squared. It is a quadratic equation on the right, and on the left hand side it's a linear term involving y. Because if we are given an equation, it should involve x and y. So we should be graphing this on the y and x axis. So the variables are actually x and y. Okay. We are given this the equation of the curve. Taking the first derivative, the derivative with respect to x of y will be dy dx. And the derivative of the right hand side will be the derivative of the individual terms on the right hand side. Okay? It seems we take the derivative with respect to x of all the terms. Okay? So the derivative of y with respect to x will be dy dx. And the derivative of the right hand side will be the derivative with respect to x of 3 plus 2x minus x squared. For the first one, this involves differentiation, so it involves the derivative or differential of a constant, and this is 0. Okay. The second one involves a constant and a function x. Okay, so if we try to take the derivative of this, it will be the constant times the derivative of that function. So it will be 2, and the derivative of x with respect to x is actually 1. The last one. This tree here involves 3 different types of differentiation. Derivative of a constant, derivative of a constant in a function, and the derivative of what we call this exponential function. And the derivative of x squared falls under the so-called power formula. So it will be nu raised to n minus 1 times du dx. So it will be 2 times x. Decrease in power by 1, that is 2 minus 1 will be 1. This is 2 minus 1, or this will just be simply 1, right? And the derivative of x with respect to itself will be 1. If we try to simplify the right hand side, dy dx now will be equal to 2. This is now 0, minus 2x. So, after taking the derivative of both sides, we are now actually given the formula on how to compute for the slope, because dy dx is actually slope. Okay, so I equated here dy dx equal to m equal to slope. So the problem is asking at the location 2 and 3, meaning if the abscissa is 2 and the ordinate is 3, for the given curve, what will be the slope? So m now will be equal to, we will be using this one, this is 2, minus 2 times 2, because at the location 2 and 3, x is actually equal to 2, and y is equal to 3, right? So m now will be equal to 2, this is minus 2 times 2, or m is equal to negative 2, and this will be the answer. The significance of this negative 2 here is that the slope of the tangent line at the given location, point 2 and 3, is actually a slope upwards to the left. So I place it here, okay? Oh, did I say upwards to the left? No, I just said upwards to the left. This is the curve. The equation of this one is actually y equal to 3 plus 2x minus x squared. And at the location 2 and 3, the problem is asking what will be the slope. As per our computation, this is actually negative 2. So actually, the tangent line, it is upwards to the left because this is negative. And this is the point of tangency. Okay? And this point here lies on the given curve y equal to 3 plus 2x minus x squared. To sketch the curve of this one, this now falls under again the study of analytic geometry. To plot the curve reduced to standard form, meaning we will reduce the given equation to its standard form. Because for the so-called conic section under the study of analytic geometry, there are standard equations in which we could determine if it is a parabola, hyperbola, okay, or ellipse, or a circle. So if we try to reduce this one to one of the standard form, we could determine if what kind of equation is the given equation. Okay, so to plot reduce to standard form, we rewrite it, we manipulate it, we transpose x squared and this to the left, so this will be x squared minus 2x equal to, we maintain 3 on the right, we transpose y to the right, this is negative y. Okay, this is now a problem of algebra, because to make this one a binomial term, we must have to find for the pure constant term equivalent, and we know the formula on how to compute for that one. We will just take 1/2 of the coefficient of the second term, then we will try to square it, or 1/2 of 2. 1/2 of 2 is just 1, and 1 square is actually 1. So the added number on the left for it to be a perfect binomial will be a plus 1. Okay, and this should be equal to 3. We add a plus 1 here. We add a plus 1 on the right to balance the equation. We are not changing the value. Minus y. And this is now factorable to the binomial term x minus 1 quantity square, because if we try to take the square of this, it is this. The square of x will be x squared, the middle term will be x times negative 1 times 2, will negative 2x, and the pure constant term is the square of negative 1, which is plus 1. So this one is actually factorable to the binomial x minus 1 quantity square, equal to. Again, the right hand side, we try to manipulate it. We bring out the negative side. A negative 1 times y will be negative y, and a 3 plus 1 is actually 4, right? But a negative 1 times a negative 4 will be actually plus 4. So these two here are actually the same. But the right hand side could be written as negative open quantity y minus 4. And this is actually a parabola. This is similar to one of the standard parabola equation of a parabola, that is x minus h quantity square equal to a negative 4p times a quantity y minus k. This is actually a parabola, in which the vertex is at the location hk. Okay. For one value of y, there will be two values of x. So this is parallel to the y-axis. For one value of y, there will be two values of x, right? Left and right. So this is actually a parabola with vertex at 1 and 4. Okay. H here is 1, k is 4. Axis parallel to the y-axis. Opening downward. Why opening downward? This is negative. Right? Since this is negative, it should open downward. So the parabola is this one. The location of the vertex is actually at the location 1. This 1, 2, 3, 4. So this vertex is at the location 1 and 4. And the specified point in which the slope is actually being asked is actually this point here. Okay? So actually this is the graph of the parabola. This is downward. This is downward, opening downward. And the point of tangency is this one. The given point of tangency is 2 and 3, and this slope at that given location is actually negative 2. Okay, that's it, guys. That's the way how to solve this problem. So this problem is a very interesting one. It involves our knowledge of the so-called study of differential calculus and analytic geometry, plus some graphing. Okay, graphing is this falls under analytic geometry. Okay, for those of you who would like to subscribe to my channel or would like to watch my channel, this is a random topic. This is an additional one. So for those of you who are taking up engineering, I've got 7 subjects uploaded already. It's a complete subject matter. I uploaded differential calculus, integral calculus, differential equation, advanced math, AC circuit, and AC machines. Okay? Or actually 6. Right? So, if you would like to learn something from these subjects, just watch my channel. Plus, the other topics are actually under short videos, and the title for the short videos are actually how to. So, it involves mathematics. It could be troubleshooting maybe, or some techniques in the so-called maintenance of our home. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.